Hi guys, and welcome to this video where we're going to look at these 5 topics for Unit 4 Independent Task 2. So in this task you had uniform distribution, you had hypothesis testing for normal distribution, we had conditional probability, our other hypothesis test which was for PMCC, so correlation, and then just a normal distribution question as well. So you should have already had a go at the 5 questions, and you should have made a mark of what level of support you required, whether it was nothing or whether it's one of the following. Remember, if you're getting to level 3 or level 4 for support, then that's a topic that requires a substantial amount of work on top of it, okay? So let's run through each of these questions. So topic 1 was a uniform distribution. So I've got the continuous random variable x represents the error in millimeters made when a machine cuts iron rods to a target length. X is continuously uniform distributed with an interval of -3 up to 3. So what I'm going to do first, before I go any further, is I'm going to write my distribution out so I know what I'm working with. Now, this is something that we should do anyway if it's not defined, but if it is defined, I still highly recommend that you do it so you can know what we're looking at, okay? So it's going to go from -3 up to 3 if I'm drawing my bar. I'm also going to put my height on my bar. So remember, it's 1 over b minus a, so that'll give me a 1/6. Now, that allows me to do some probabilities. So for part A, I want the probability that x is less than -2.3. So I'm simply going to look at the area of the bar. So -2.3, let's say that's about there. I want this area by here. So I already know what the height is. The height's a 1/6. And I need to basically find out what the base is. So I want to know what's the difference between these two, which is going to give me 0.7 if I look at the difference between these two here. Okay, that is going to give me 7 over 60 as my final answer. Now, if you guys are decimal, that's completely fine. Okay, but if we want to keep things more accurate, we are going to try and keep them as a fraction. So for part B, we've got something slightly different. We've got the modulus of x being greater than 2.0. Okay, so what we got to think here is what value should this be? So remember, we got to do the plus or minus version. So the first version is when it stays the same. So that's the positive version. Or, so adds, or the probability is negative version. But let's remember with modulus, when we flip the negative sign to a negative sign, we got to also flip the inequality. Okay, so when it greater than 2 or when it less than -2. Okay, so again, I've got a 1/6 times by my base, which would be, in this case, I want it 3 minus 2, which would be 1. Okay, plus a 1/6. And then same thing here, I'm going to do -2 minus -3. Okay, I'm going to type all that in my calculator, gives me a 1/3. Okay, so this here, this modulus of x being greater than 2, this is that when it cuts, when the machine cuts it to the target length, okay, the error is outside of 2 meters. This is outside of 2 meters, of 2 millimeters. Okay, now if we read part C, I've got 10 rods are cut. Calculated probably that exactly 6 are cut within 2 millimeters. Okay, so I'm doing the number of rods and how many of those rods. So I've got a binomial distribution being formed here. And I've got some other things to deal with. So first of all, let's do let y. Let's do a new letter. And it's going to be the number of rods that are cut within 2 millimeters of target length. So if I'm writing out my distribution now, we said it was binomial because I got the number of, okay, so it's binomial and there was 10 rods that are being cut. Now the probability of it being within 2 millimeters, well, the probability of being outside 2 millimeters we did in part B was 1/3, so probably being within 2 millimeters must be 2/3. Okay, and then I want the probability that y equals 6. Okay, and we should be using our binomial formula when we got n equals 2. So I'm going to 10 choose 6 times by 2/3 to the power of 6 times by 1/3 to the power of 4 in this case. Okay, remember the two things in my brackets here, 2/3 and 1/3, that makes 1, and 6 and 4 make the grand total of 10. Okay, so if I type that in my calculator, I get 0.2276. Now, please still use binomial PD to check your answer. If you've got an equals to, so you've got a PD function, then let's make sure that we're using the formula as much as we possibly can. Okay, so for question 2, we got a normal hypothesis question. Now, there's much more to this question as well, which we'll get to now, but we need to make sure that the key things, like if, for example, down here, we see significance tests. So we kind of already know towards the bottom, we're going to be doing a hypothesis. But let's not worry about that now. The first thing we got is the mass of a European water voles are m grams. Okay, so I've already got my letter defined. Okay, this is normally distributed with a standard deviation of 12. Okay, so it doesn't tell me the mean as such yet. So I've got 12 squared there. Given that 2.5% of the water voles have a mass of 160 grams, so I don't know the mean. So I'm missing the mean. Find the mean mass. That's what needs to be defined. So I'm missing a mu or sigma. So I'm going to have to use Z tables here. So I'm looking at part A. They told me the probability that the mass is greater than 160 is 0.025. Okay, now I need to use inverse normal. So before I do, I'm going to do it less than, which would be the opposite, so 0.975. And I'm going to change it to its Z tables. Okay, now we should remember our Z tables is X, which is 160, in this case, minus mu, which we don't know, all over sigma, which is 12. Now, obviously, what this allows me to use, so to do here, remember Z is normally distributed with 0 and 1 squared, so that helps me out here. If I type it into my calculator using inverse normal, I'm going to get 160 minus mu over 12 is 1.9599. Now, I'm not going to round it as such yet. Okay, it's important I do all my calculations first. Now, I can calculate mu here. So I'm going to times by 12. I'm going to do 160, take away that answer. Okay, that's going to give me 136.48 grams. So that is my mu now. So make sure if we're missing the mu or sigma, we use our Z tables. Now, if we go to part B here, okay, what I'm going to do first, I'm going to rewrite my distribution as 136.48 and then 12 squared. Okay, I'm going to use that to my advantage now. So for part B, let's go back up and read it. 8 water voles are chosen at random. Find the probability that at least 4 have a mass greater than 150. So there's two things. First of all, again, look, I'm testing out of the 8, at least 4 of them, so that's a binomial. But it talks about it being greater than 150, which I don't have at the moment. So let's do that bit first. So I can do it being greater than 150 now. I'm just going to use my calculator. That comes out as 0.1299. So that's the probability that one of them is greater than 150. So again, I'm going to do let's go with X equal number of water voles with a mass greater than 150. Okay, so I've got X is binomially distributed again, and I've got 8, and my probability is what I've just found above. Okay, and I want the probability that X, and then at least 4 would be greater than or equal to 4, which obviously I can't do in binomial. So 1 minus the probability that X is less than or equal to 4, less than or equal to 3, sorry. And again, I'm just going to go to my calculator. So I'm going to type this bit into my calculator, do 1 minus here. I end up with 0.0129. Okay, so again, we can link normal and binomial together. That's quite a common thing that they like to link together. So we need to be wary of that. Right, so part C, here comes my hypothesis test. So the first thing, European water rats, I'm talking about something else, has an n grams, is normally distributed with a standard deviation of 85. So I've got this new thing, n, okay, and it's normally distributed, which is a bit annoying because they're both n, and I know the standard deviation is 85 grams, 85 squared. A random sample of 15, so that's my n. Rats were taken from the sample, and the mean mass was found to be 875. So this here is my observed amount. State your hypothesis clearly using a 10% level of significance. Test whether the mean mass is different to 860. So it's telling me the mean is 860. So the first thing I'm going to do is H0 and H1. H0 is what currently mu would be, so 860. and they want me to test that it's different, so just not 860. I'm going to go from there. So n equals 15, which means I need to do n bar, which would be normally disputed. Now let's remember 860 is going to stay the same. I'm going to have 85 squared all over 15. Okay, now I always say, let's write this on the side. Sigma would be 85 over root 115. I always say do that because this is what's going to go in your calculator. Okay, now you've got two ways of doing it now. You can either do p-value version or you can do critical regions. Because we've got inverse not all, we're going to do critical regions way. Okay, so the first critical region is going to be the bottom end. Now I'm doing 10%, so I'm going to half it and do 5% at the bottom end of the tail and 5% at the top end. So x being less than a should be 0.05, which I can go straight to my calculator and find what a is. That's 823.9. And we'll look at the top end of the scale, so x is greater than b, again being 0.05. But I need to change that. That's probability that x is less than b is 0.95. So b comes out as 896.1. Okay, so my two critical regions are x being less than or equal to 823.9 or x being, so x bar being greater than or equal to 896.1. Okay, and I'm basically going to say is what I observed inside. So 875 is not in the critical region, so I'm going to state that. 875, let me go across a little bit, there you go, is not in critical region. Therefore, insufficient evidence to reject H0. Insufficient evidence to reject H0. Okay, and then you need something in context as well. Okay, so in terms of context, let's think about what it says here. It's going to be insufficient evidence. And again, I'm going to steal what the wording of the question says. So test whether the mean mass of water rats is different from 860. That's what I'm going to say. Insufficient evidence to say that, and then I'm going to go from there. So let me write it in a different color. So insufficient evidence to suggest the mean mass of rats is different from 860. Okay, make sure you've got that purple line that I've got here. Okay, you've got to have something in context. You will just be losing marks for the sake of not writing an extra sentence. It's really, really important that you do so. Okay, so question 3, we got a conditional probability one. Okay, so bag contains 6 red balls and 9 green balls. A ball is chosen at random. Its color is noted. The ball is placed to one side, so it's not put back into the bag. A second ball is chosen at random. So part A, draw me a tree diagram for that. So I've got my first options, which are picking a red or picking a green. And then I'm going to choose another 2 from there, which again, my options are going to be red or green. Red or green. Okay, so the first time I've got 6 out of the 15 that are red and then 9 out of the 15 that are green. Now, if I follow the top path, I take a red out. So I've got 1 less red and I've got 1 less overall. But I still have, sorry, it should be 9. I still have the same amount of greens. Okay, whereas if I follow the bottom path, okay, I've got the same amount of red, so I've still got 6. And I've got 1 less green. Okay, so there is my tree diagram to go with this. Find the probability that both balls are green, so the probability of a green and a green. Again, I'm just going to follow my branches, so 9 over 15. Sorry, that should be over 14, that last one. Times 8 over 14. Okay, which, again, I'm just going to type in my calculator. It comes out as 12 over 35. Okay, that's part 1. Part 2 wants a probability of a different color. So that's a red and a green or a green and red. So you need to think about all the possibilities. So that's a red or a green plus a green or a red. Okay, so if I do each one separately, that's 6 over 15 times 9 over 14 for the first one. And the second one's going to be 9 over 15 times 6 over 14. And again, I'm just going to type all that in my calculator. Okay, it gives me 18 over 35 as a final answer. Now, part C, further balls are drawn from the bag and not replaced. Find the probability that the third ball is red. Okay, so there's quite a lot of options here. For the third ball to be red, I could have any of these happen in the first place. So I can get a red and a green and a red, or a green and a green, and then my third one being red, okay? So those are my options. So I've either got a red and a red the first time, and then a third red, or I've got the probability of a red and a green, and then a red, or I've got the probability of a green first, then a red, and then my third red, or I've got the probability of two greens, and then a red. Okay, and I'm basically going to work out the probability of each of these. The first one, I know it's 6 over 15 times 5 over 14, and then I take another red out, so I've got 4 over 13. So this is where we've got to be careful with what's going on here. Next one, I've got probability of red first, so 6 over 15. Then a green, so that's 9 over 14. Then it's over 13. I've already taken one red out, so it's going to be 5. Next one, green first, is going to be 9 over 15. Then a red, so 6 over 14, then 5 over 13. And then the final one is two greens, so 9 over 15 times 8 over 14. And I haven't touched any reds yet, so I've still got 6 of them over 13. And again, I'm going to type all that long line there into my calculator. Gives me 1092 over 2730. Okay, or if you've rounded it to a decimal, that's also fine. And make sure you've got the equivalent fraction to it. Okay, and then I also want to find a probability that it takes just 4 selections to get 4 green balls. Okay, so there's only one way of that happening, and that's me getting 4 greens. Okay, any other way, in 4 selections, I don't get 4 greens. So the only option I have is a green, a green, a green, and a green. Okay, anything else, 4 selections, I'd have 1 red, which isn't going to give me 4 greens overall. Okay, so I'm simply going to go for that. So 9 over 15, I take one out, so 8 over 14. I take one out, so it's 7 over 13. I take another one out, so it's 6 over 12. And again, I'm just going to multiply them all together. It gives me 6 over 65. Okay, so make sure that when we're using these tree diagrams and things like that, that we're thinking of all the different possibilities that we can use. Right, question 4, we've got our other hypothesis test, which is the PMCC. So this is testing for correlation. So the data shows below shows the height of sea level, X meters, and the temperature of Y at 7 a.m. on the same day in summer in 9 places in Europe. So there's my 9 places. Now 9 is always going to be important because that's going to be how many people there are or how many things there are. The product moment correlation coefficient is this. They tell me it's that. So I'm just going to write my key bits of information down here. Now, obviously, with WJC, we don't get expected to calculate this, but you'll probably see with other examples, you are. So you can use your calculator for it. Okay, you can look up online how you can do that. Use this value to test for a negative correlation at 5%. Interpret your results in context. So the first thing, again, is going to be H0 and H1. Now, what's nice about H0 is that it's always, no matter what I'm doing in this case, equals 0. So I'm testing that there's no correlation first. Now, they've then said a negative correlation, that's less than. Okay, so what I now need to do is I need to go to my stats tables and find my critical value. Okay, now to do that, I need to know what n is, so how many things there were. There was 9. It's 5%, and in this case, it's one-tailed. Okay, and I'm going to go to my values and I'm going to find my critical value. Now, you'll notice in the tables they're all positive, which is fine if you're testing for a positive correlation, but when I'm testing for a negative, all I do so I put a negative sign in front of it. Okay, that's that. My test statistic is my one I had up here, so 0.975. Okay, well, you can draw a line. So this would be -1. Let's say 0 is here. My critical value is here. That's minus 0.5822. And everything this side, so more extreme, further away from 0, okay, would be my critical region. And my critical value is about there. It's in my critical region, isn't it? Okay, so I need to state that. Okay, so I'm going to go test statistic is less than critical value. So in critical region. Okay, if it's in the critical region, it's sufficient evidence, so therefore sufficient evidence. To reject H0. Okay, and then I need context. So this is what I set my sentences every time the same as, so it helps me out. So sufficient evidence to suggest there is a negative correlation between, and I'm going to state what they're between. I'm going to use the wordings here. Height above sea level and temperature. Make sure you put them what they're about, so what it's between. Don't just write there is a negative correlation. Like, what does that mean? You have to say what it's between. So height above sea level and temperature. Okay, so the final one, we've just got a normal distribution question to finish off. So let's read it carefully. I've got the heights of a large group of men are normally distributed with a mean of 178 and a standard deviation of 4. A man is selected at random, and so on. So the first thing I need to do, okay, there's nothing defined, so let's do let x equal the height of men, of a man. Okay, so x would be normally distributed, and I've got means 178, standard deviation is 4, so 4 squared. So find the probability that he is taller than 185, so that x is bigger than 185 centimeters. Okay, I'm just going to go to my calculator. Lower value 185, upper value something really big. Here's my 2 bits here, so 0.0401. Okay, for part B, find the probability that 3 men selected at random are less than 180. So the first thing I need to do is find out what's the probability of 1 man is less than 180. Okay, again, I'm going to go to my calculator. Gives me 0.6915. Okay, or sorry, 14. Right, then from here, okay, I want the probability that probability that 3 men are selected and a random are all less. So I want the probability that 1, 2, and 3 are all less than it. So if I could go and try and do binomial and do it for 3 men, but if I'm doing it for 3 men, I'm just going to cube that. So for 3 men, I'm going to do 0.6914 cubed. Okay, so it's probability that 1 times the probability the second is and times the probability the third is. Okay, gives me 0.3306 as my final answer. Right, then we have part C, okay, where we need to be careful a bit more with this one. A manufacturer of door frames wants to ensure that fewer than 0.005 of men have to stoop to pass through the frame. On the basis of this group, find the minimum height of the door frame into the nearest centimeter. Okay, so I'm looking at inverse normal here. On probability that x needs to be bigger than some height. Okay, just to make sure no one needs to stoop down. Needs to equal 0.005. Okay, and I'm going to do my normal thing. So it needs to be less than to do inverse normal. So that'd be 0.995. And then I can go straight to my calculator. It's going to give me x is 188.03, and it wants it to nearest centimeters, so it needs to be 188 centimeters. Okay, so as I said, you should have already had a go. Now you can mark these and make sure we're okay with them. Make sure you made a note of the topics you need to go over, and you can spend that time now ready for the next time, okay? But apart from that, really, really well done so far. Keep going, and I'll see you in the next set of tasks. Thank you.